Welcome to The Explainer. So today, we're diving into a theory that's, well, pretty out there. We're not just talking about tweaking a few equations. This idea proposes a completely new foundation for reality itself. And what's wild is that it connects some really ancient mathematics with the absolute biggest questions in cosmology today. All right, let's just jump right in with a question that's going to make you rethink, well, everything. We usually think of the universe as a bunch of stuff. You got your planets, your stars, all these particles, and they're all moving around inside this giant box we call space, right? But what if that whole picture is completely backwards? What if the universe isn't made of things in motion at all, but is just motion itself? So, why would anyone even come up with an idea that sounds so out there? Well, to get it, we really need to look at the state of physics today. Because honestly, we're at a major crossroads. We've got these two amazing theories that explain so much, but they just don't get along. So on one side, you've got Einstein's general relativity. This is the big stuff. It's how we understand planets, stars, entire galaxies. It works beautifully. Then on the other side, you have the Standard Model. This is for the tiny stuff, particles, forces, you name it. And it's incredibly precise. The problem is, even though they're both these monumental achievements, they're built on totally different math. They describe two different universes. And at the end of the day, they are completely, fundamentally incompatible. And this huge disagreement, it leaves us with some of the biggest mysteries in all of science. I mean, think about it. We have no idea what 95% of the entire universe is made of. We call it dark matter and dark energy, but honestly, that's just a name for something we can't explain. And then there's other weird stuff in the data, like this strange alignment in the afterglow of the Big Bang, something scientists have nicknamed the axis of evil. Our best theories just can't account for it. So, what if the answer isn't just about finding another new particle or adding a little patch to our current theories? What if we have to go deeper? What if the solution means we have to rethink everything, right from the ground up? I'm talking about the very nature of space, of time, of what it even means to exist. And that is exactly where this idea, the Bundy Reciprocal System theory, or BRSt for short, comes in. See, it doesn't start with matter or energy or fields like our other theories do. No, it starts with something way, way more basic. Just motion. And this is the core idea that changes the whole game. Forget about particles moving around in empty space. The BRSt says the universe is the motion. Everything you see, everything that exists, a star, an atom, even you, it's all just a really, really complex pattern made out of this one fundamental thing, motion. Okay, so what is this motion? The theory calls it scalar motion. Imagine it like a pure vibration, something that has an amount, a magnitude, but no specific direction. It's just vibrating. But here's the really mind-bending part. In this system, space and time aren't separate things. They're not a stage and a clock. They're two aspects of the exact same thing. It's like two sides of a coin. You can't have one without the other. For every little bit of motion, if you have more space, you have to have less time. And if you have more time, you get less space. They are totally reciprocal, constantly balancing each other out. All right, so if the universe is just this sea of motion, how on earth does it organize itself into, well, us and galaxies and all the complexity we see? This is where it gets really interesting. The theory claims the structure, the blueprint for all of it, comes from a really, really old mathematical symbol. That blueprint, it says, is something called the tetractys. Now, this is a triangular shape made of 10 dots that was super important to the ancient Pythagoreans. I mean, they considered it sacred, a symbol for the harmony of the entire cosmos. And this new theory? It basically says, yeah, they were right, and takes that idea literally. It uses the tetractys as the actual mathematical template for building a universe. And you can see how it works. It literally builds reality from the ground up, just by following the logic of that symbol. So you start with 1 point, the monad, a single point of unity. Then 2 points, now you've got a line. That's your first dimension. Add a third point, and boom, you can make a flat plane. You've got 2 dimensions. And finally, you add that 4th point, and you can create a volume, the tetrad. And that gives us the 3-dimensional world that we all know. Okay, and this is where we get to one of the theory's biggest aha moments. It turns out that the ways you can combine things at that 4th level, the one that makes a volume, naturally creates a mathematical pattern, 1, 3, 3, 1. And the theory says that's not a coincidence, not at all. It argues that this exact geometric pattern is the reason why all the elementary particles in our universe are organized into the families that they're in. All right, so we've got this new foundation made of motion and a geometric blueprint from the Pythagoreans. The big question is, does this actually help us solve any of those huge cosmic puzzles we mentioned earlier? Now, the theory does have things to say about dark matter and dark energy, but for now, let's just focus on two really cool examples, that weird axis of evil and the structure of matter itself. So first up, let's go back to that weird alignment we see in the heat left over from the Big Bang. Remember, our standard theories assume the universe should be pretty much the same no matter which direction you look. So when we see this huge, large-scale pattern, it looks like a mistake, a flaw in the data or the theory. But from the BRSt point of view, this isn't an accident at all. It's a watermark. It's a signature that was left behind, a predictable result of the deep, three-part symmetry that the tetractys structure builds into reality right from the very beginning. So it's not a problem to be explained away. It's evidence for the theory itself. Okay, on to the next puzzle, that whole menagerie of elementary particles. Why are they organized the way they are, in these specific families and generations? I mean, our standard model is fantastic at describing that structure, but it has zero explanation for why it's that way and not some other way. The BRS says the answer is simple, it's geometry. The way particles are organized isn't random at all. It's a direct, unavoidable result of the mathematical rules of that tetractys blueprint. According to this idea, the laws of matter aren't just some arbitrary rules. They're literally written into the fabric of space and time itself. So, at the end of all this, what's the big takeaway? With a theory this ambitious, it's not just about whether it's right or wrong. It's also about the spirit behind it, about a different way of thinking about science itself. You can tell this theory is presented with a real respect for history. It's not trying to throw everything out. Instead, it sees itself as standing on the shoulders of giants like Newton and Einstein, but also reaching even further back to that ancient Pythagorean search for harmony. It's trying to continue that conversation and bridge all these big divides we have in physics today. And what's really important is that the people behind it aren't saying, here it is, the final answer to everything. Not at all. They present this as a new starting point, a completely fresh perspective to help us start asking new questions and look at the universe in a different way. So really, it's an invitation for all of us to step back, question our most basic assumptions, and just see if starting from a different place might lead to a more complete, more beautiful picture of the universe. It's a call to join in what the theory's creator calls the shared adventure of reason. And all of this leaves us with one last big thought to chew on. For centuries, physicists have had this gut feeling, this faith, that the ultimate laws of the universe should be beautiful and simple. This theory is definitely elegant. But does that automatically mean it's true? That's a really good question to ponder.